We'll now explore a basic Starling project. This project simply creates a Starling instance that we can use, so basically a Starling view in our application. And anything within this view is going to be 3D accelerated. All we're going to do though is simply draw out an asset, an image asset, and display it in our device. So if I go ahead and run this application, we can see that all it's doing is pulling out my avatar here. So how do we get that to work? So we already have the Starling library in the form of a SWIC inside of our application, and we have this main ActionScript file here. This is our main class, and it's what drives the rest of the app. You'll notice here we're importing two different things. We're importing flash.display.sprite, which is one of the core ActionScript classes. And then we also have starling.core.starling. So this is what you have to use to get Starling running on a device. Here we also set a metadata tag declaring the width, the height, the frame rate, and so forth. Now, inside of this main class, we're extending sprite. In this case, it's flash.display.sprite. So even in Starling, you have to start with one of the core Flash classes. What we do is basically create a Starling instance that everything else goes into. So here we declare that, so private var Starling, and we data type that to Starling. And then we create our public function main. Now, if you haven't worked in ActionScript before, when you have a class of main with a function of main, that basically gets initiated and run as soon as your class runs. It's like an initialization function. So here we set Starling equal to a new instance of Starling, and then we pass in the ActionScript class that's going to drive everything else. So in this case, we called it start app, and then we bind that to the current stage. The stage is just the stage in which we're working on inside of Flash, and Air in this case. And then all we have to do is say starling.start, and it starts up Starling using this class. So that class itself, you can see, is right here, start app. Let's open it up. And up top, we're importing a number of different things. This is just a basic package here. And we import flash.display.bitmap, and that's the only core Flash class that we're actually pulling into this project. The next four classes are all Starling classes, as you can see. So we're calling starling.display.image, sprite, and texture, as well as the core Starling classes. For our class declaration, we declare public class startup extends sprite, and in this case, we're extending starling.display.sprite and not one of the core Flash display object sprites, as we did over in main.as. So here, when we extend sprite, we're actually extending one of the core Flash classes. Inside of our actual Starling bits, we're actually using a Starling sprite, not a Flash sprite. The first thing we do inside this class is we embed our actual ping image that we want to display inside of Starling. And using this embed directive, it makes it so it's actually part of the application, and you don't have to invoke it over a URL or grab it over a file command or anything like that. And then we can declare a number of things. The first thing is that we declare Lebrec as a class. Now, of course, you can call this whatever you want, depending on what you're bringing in. I'm bringing in myself, so I declare it with my name. And you declare that as a class, and as you'll see later on, we're able to create a new bitmap from that. The bitmap itself is actually one of the core Flash classes. So here we declare bitmap as a bitmap, texture as a texture, and image as an image. Now again, just like with our main class, if we have a class start app and we have a function start app, that startup function is going to be our initialization function. It's going to run automatically. So what we'll do here is create a new bitmap. So it's actually a new Lebrec class, which we declared here. It's utilizing that ping, and it is declaring that as a class. So all we have to do is say bitmap equals new Lebrec. And then here texture equals texture, which is the Starling textures.texture class, and from bitmap. And then we pass in that bitmap image we just created of that ping file. So here we're just saying, I want to create a texture from a bitmap, and this is the bitmap I want to create that texture from. When we're working in 3D, we have to work in textures and not in bitmaps. And that's the reason for that. Now we say image equals new image, and we pass in that texture to the image. So again, image is a Starling image. So this is one of the Starling classes that we're using here. So starling.display.image. So this is something that can actually be added to our Starling view. Here all I'm doing is setting our image width to starling.current. So that's the current instance of Starling we're working in, because you can have multiple instances of Starling working at once. And then we say native stage width. This gives us the width of the actual stage. And all we're doing here is setting our scale Y equal to our scale X that we inadvertently declared up here when we changed the width. So this is going to keep everything, the resolution exactly 1:1. And then we say add child image, and that should add it to our display. I also have a little trace statement here so that we can see that come out, as you can see right here when I ran it before. And that's basically all this application does. It's a good starting point, though, for working in Starling. So there is one more thing you need to know, and that is within our application descriptor file for air. If I go in here, we have all of our normal stuff up here. We give it a name and so forth. But down here, we go down, down, down. And right here, render mode, we set that to direct. Initially, this render mode tag is actually going to be commented out. So you're going to want to uncomment that and set it to direct mode, the default being auto. Direct is what you always have to use when you're doing something in Stage 3D. Starling is utilizing Stage 3D. Therefore, we must declare render mode direct.